Okay, so this next video is going to be recapping Laplace transforms up to this point. And when I went through like the outline of what we would do in class today, I didn't mention this because what we're about to do isn't going to be anything new. It's all review of what we've done up to this point. But I think that we learned so many different things that are kind of a jumble in this section that it helps now that you've had some practice with them and really have a good feeling for them to again remind you of the context in which those things are useful. So if you feel like a pro of Laplace transforms, then you can skip this. But otherwise, this is intended to help you know when to use the different rules for Laplace transforms. So first of all, why did we do this thing that is so different from what we did on exams 1 and 2 for solving differential equations? And Laplace transforms are useful for solving IVPs. You know, we need those initial conditions to apply our derivative property with non-homogeneous parts that take the Laplace transform of both sides, deals immediately with non-homogeneous parts without the extra thinking we had to do for like undetermined coefficients and variation of parameters. But the limit here is that we have only ever used Laplace transforms on constant coefficient problems of any power, that is, of any order, because we don't really know how to take like L of like t cubed plus 1 times y prime. That's not something that we've dealt with. So that's when Laplace transforms are useful. And the challenges with Laplace transform are going to mostly come from after you find y equal to some stuff. Then getting the solution to the ODE, y equal to L inverse of y, so L inverse of whatever that stuff is kind of like a puzzle. So you need the correct method for finding that inverse, but you also want the easiest one. So maybe more than one Laplace transform property would work for you, but only one saves you a lot of effort. And then I really want to talk about the properties that we've learned. And to that I say, look at your table of Laplace references. It's probably really long at this point because we've covered so much stuff, and it might even be starting to get like kind of disorganized. What we're going to do is we're going to go down the list of those references in the order we covered them and talk about the context in which you use each thing. So this is like another reference, but it's when to use the different properties. And I went ahead and wrote out all the properties first so that you can maybe just like next to that same table that you already have, write down any tips that like you think are useful when we're talking about this of when to use those properties. Because you really do want all your Laplace stuff in one place. So the basic rules we covered on that first day of like guided self-exploration, you learned the integral definition for Laplace transforms. And to that one I say avoid if possible. I don't like that property. Most of the things where the integral is manageable for you already appear in the Laplace transform table, so this won't get a whole lot of use for you. We also covered the linearity property, which you should be able to use without thinking. You should see Laplace transforms of linear combinations of things and immediately know you can break them apart. That should be the easiest part of any Laplace transform problem. L of y prime, y double prime, so on and so forth will come up a lot. Just be careful about signs. The formulas themselves, I think, are pretty straightforward, especially if you practice it a few times, but it's easy to make little mistakes. And then the tables of L and L inverse, I would say use whenever possible. And hopefully you're starting to get like a memory of the types of functions that do show up in your table. So like when you see s over s squared plus 4, you know to go check the cosine thing and figure out the format that you're supposed to be using. So those basic rules, for the most part, either we don't use them anymore or they should be pretty reflexive. The real trickiness comes from all the different rules we learned after that. The first of which were the like translation group. So this L of e to the at times f of t equal to f of s minus a. That property is one of the most direct. Use if you have e to the some number times t times some function. And then that's all there is to it. The inverse property, really the only way that you're going to recognize that you need to use it is going to be if you use the forward direction you need this backwards direction L inverse. So if you did this thing and introduced s minus a's, then you should know that you're going to have s minus a's that you undo with the same thing. And just one tip here is that you might need to put f into s minus a form. So a lot of the section is clever algebra. In that one, you would like add and subtract the same number so that you have like an s minus 3 or something. And then you can use this property so that it matches the exponent that you introduced to start. After we did those two translation properties, we did the piecewise translation property. So the forward direction, L of f of t minus a, u of t minus a equal to e to the minus as f of s. That one comes up when you have piecewise functions f. The tips I have for this property are that, first of all, building or turning is easy. Turning piecewise f into this representation using step functions is tough. So I tried to give lots of practice with that because it's one of the harder things we do in this section. Go back to that like flexible reference I told you about if you're still struggling with this. And then you have to make sure to get that f of t minus a form. Again, using clever addition and subtraction. So if you only have like t squared, actually that one's going to suck. If you only have t times u, but you actually need t minus 3 times u, then you add and subtract 3u to match the format that you need. The inverse property, you know that you're going to have to use. If you had u or delta in the original ODE. So the first is just if you had u's when you set up your Laplace transform problem, then you're going to have to use this property to undo them again. And then this lesson we learned that if you have deltas, it's going to do the same thing to you. And then the tips here to be careful about are just that you need to make sure to plug in that t minus a to f. But otherwise, this is actually pretty straightforward. when you compare it at least to the other direction, where there's a lot of funny algebra to get the right outcome. We actually did an example in this section. Right here, once we knew that we had to do it, when that t minus a appears in the inverse direction, it's just a matter of plugging a different number in, so it's a lot easier. I know that we're right about at 10 minutes, so I'm going to stop here and then we'll finish out this table in the next video.